Now, the big question, of course, is, in a sense, she is not here, right? We see her slides here. I'll see if we can find her coming here. I should say, Karen suffered from a strained ankle before getting here, but she has been extremely generously been moving around university at all sorts of places, local homes, restaurants, and other places. And now she's here.
With a great deal of help.
If the ankle becomes too strained. But Karen, it's great to have you. Please take us away.
Thank you so much. That was an amazing introduction, really beautiful. I'm not sure the last time I heard lattice gauge theories mentioned in public. Yes, of course, it's entanglement all the way down. So I'm very honored by this invitation, and my task today is to address issues related to our common future. So, of course, we are being told now that our common future is to be traced to the fact that we have entered a new epoch, sometime around 1950, with the global dispersal of radioactive materials from nuclear bomb tests. What kind of future does this portend? As physicist I.I. Rabi, a student of Oppenheimer's, said when he witnessed the Trinity test in 1945, the equilibrium in nature has been upset and humankind has become a threat to the very world it has inhabited. The Doomsday Clock of the Bulletin of Atomic Scientists, introduced in 1947, represents scientists' estimation of how close we are to global catastrophe. Nuclear Armageddon was on the radar screen, and if the bombs didn't destroy your city, nuclear winter is to be our common fate and ultimate demise. At first, the setting of the clock was based purely on a sense of temporal distance to nuclear apocalypse. But in 2007, the bulletin expanded its measure to include climate change, in addition to the prospect of nuclear annihilation, as the greatest threats to humankind. And when it did that, the clock jumped to 3 minutes to midnight. The closest it's ever been is 2 minutes to midnight, and that was in 1953 after the testing of the hydrogen bomb. So it's a nonlinear device that clocks social and political events. The hands of these doomsday clock are recalibrated once a year. So this is a rather strange clock, a nonlinear, non-mechanical symbolic clock, a bit of, in a sense, sincere theatrics that is an important statement of the concern of the scientific community. It doesn't simply move forward, and it isn't synchronized to one particular physical phenomenon, but rather to global politics and technological progress. And its measure is from the endpoint rather than some origin point. So time is synchronized to the apocalypse to come, a future of no future. This is time fixated on its own demise, a device tuned to the Cold War, the threat of total war taking hold of our unconscious and distracting our attention from the ongoingness of war. I'll come back to this point in due time. Of course, the Doomsday Clock is not the only clock with fixed hands that invokes a sense of catastrophe. 8:15 is the time known as the time when time stood still. Hiroshima, August 6, 1945, the time when time was arrested, the time of time's demise. Clock mechanisms melted by the heat of the blast. The city clocks, clocks in plazas and stores and homes, on wrists and in pockets, were forever synchronized to one particular moment, the time when time was annihilated. So the particular pocket watch that you see a picture of here is all of a son had left of his father. The hands of time that you see are not really actually hands anymore, but it is the flash-burned hands on the face of time. The Hiroshima Peace Clock Tower is a tower that you see in the color photograph at the bottom right, is a clock that actually rings every day at 8:15 a.m. And there's another famous Hiroshima clock that's in the Peace Memorial Museum called the Peace Watchtower. And this has a clock synchronized not to war, but to peace. It is reset back to 0 every time there is a nuclear test of significance, which is the measure of major threat to world peace. Now, the third type of clock that I want to introduce you to today are atomic clocks. So even clocks themselves went atomic. Global time, universal time, cosmic time. Another byproduct of the war governed by quantum physics. The total colonization of space-time synchronized to the heartbeat of an atom. Globalism is tied not only to the militarization of space, but also of time. So the idea of the atomic clock was first introduced by physicist I.I. Rabi in 1945, and the first atomic clock became a reality in 1949. The latest atomic clock is so precise that it won't gain or lose even 1 second in approximately 15 billion years, the approximate time of the age of the universe. And you might say to yourself, why on earth would anybody need such a hyper-accurate clock? Well, actually, nothing less than the global economy requires such a clock. The mechanical guts of capitalism, including GPS, telecommunications, and high-speed transfer on internet lines, depend upon it. So all three of these clocks are tied to quantum physics. Quantum physics gave birth to the atomic age, and it is no secret that it is deeply entangled with the military-industrial complex. Each of these clocks, even the nonlinear ones, synchronized to political events, are arguably measuring devices attuned to what Walter Benjamin very poignantly called homogeneous empty time. Whether calibrated to the future, to individual events, or successive ticks of the clock, the face of time is tuned to this moment, where now is the thinnest slice. And each successive moment replaces the one before it. So this is the time of capitalism, colonialism, and militarism. But homogeneous empty time is not the time of indigenous and fourth world peoples. It is not the time of the Inuit or Aboriginal peoples, Native Americans, or Pacific Islanders. And evolutionary time is not revolutionary time. As the Afrofuturist musician philosopher Sun Ra issues his wake-up call, it's after the end of the world, don't you know that yet? It's after the end of the world, don't you know that yet? The first atomic bomb was not the one dropped on Hiroshima. It was dropped on Americans, or rather, Turtle Island's original inhabitants, the indigenous peoples of the Southwest United States. The world's first atomic bomb was detonated on July 16, 1945, in New Mexico, home to 19 American Indian pueblos, 2 Apache tribes, and some chapters of the Navajo Nation. At the time, an estimated 19,000 people lived within a 50-mile radius of ground zero. And the so-called Cold War wasn't cold at all. Nuclear war, the exploding of some 2,000 nuclear bombs, was being conducted the whole time against the fourth world and indigenous peoples, and it's still happening. In our post-atomic age, time is synchronized to the apocalypse to come, the present caught in a pose of holding its breath in an attempt to forestall the onset of nuclear war. So this sense of temporality is fixed and fixated on the event horizon of total annihilation, calibrated to fear and the illusion of the ongoingness of war in our hyper-militarized present. Masahide Kato calls this totalizing view the globalized space-time grid, the obliteration of the history of undeclared nuclear war, against Fourth World and indigenous nations. That has been going on since World War II, beginning with the Trinity test in 1945, then the bombing of the Marshall Islands, Bikini Atoll in 1946, and so on. So the equation nuclear future equals no future is a version of the future, capital F, that takes attention away from the hot wars of the so-called Cold War period and continuing into the present. This future, capital F, is built on the erasure of the past, the history and the present ongoing violences of colonialism. So the notion that there is something called the future already assumes a particular conception of time that finds no traction in indigenous cosmologies and ontoepistemologies. In his article, Indigenizing the Future, Daniel Wildcat, drawing on the work of indigenous philosopher Vin Deloria, lays it out this way. It is of critical importance that some cultures express history as primarily temporal and others express history as fundamentally spatial in character. Once history as time is universalized and human beings are, so to speak, all put on the same clock, it is inevitable that the big picture of human history, that in the big picture of human history, some people will be viewed as on time, ahead of time, or running late. It makes little difference that the clock hands rotate in circles, he says, for they are thought of and acted on as if they were wheels moving down a single road called progress. This road ought to be the ultimate metaphor for Western civilization and modernity, for it is an ideological abstraction, as John Mohawk concisely elaborated in his essay, The Right of Animal Nations to Survive. The metaphysics of progress presents itself as the greatest threat to the future biology of the planet. American Indian or indigenous traditions resist ideas of universal homogeneous world history. There is no single road per se to human improvement. There are many paths, each situated in actual places, such as prairies, forests, deserts, and so forth, and environments where our tribal societies and cultures emerged. The experience of time and history are shaped by places. Or, as the South African student activist Leanne Naidoo puts it, who can tell the time? What time is it? To read the time is a complex matter in this society, both post-apartheid and not. Revolutionary activists, she says, are time tellers. We are in the midst of an intense politics of time, she writes. It is the pain that comes from being forced back into the present world after a premonition of a different one, like a trap or a curse. The student activists are time travelers. They have been working on the project of historical dissonance, forcing an awareness of time. They have been experimenting with hallucinating a new time. The first task has been to kill the fallacies of the present, to annihilate the fantasies that all is well. The second task is to arrest the present, to stop it, to not allow it to continue to get away with itself for one more single moment. And when the status quo of the present is shut down, the third task, and these have been the moments of the greatest genius in student movement, she writes, it is to open the door into another time. It is difficult to work on the future while the present continues apace. There has to be a measure of shutdown in whatever form for the future to be called. So alternative titles or subtitles for my talk might be Whose Future, Whose Time? Or Undoing the Future, capital F, or Decolonizing Thinking About the Future. The rest of my talk, I'm going to talk and not read, and I'm going to talk about different kinds of temporality, different notions of temporality that quantum physics gives us. So this is both continuous with and discontinuous with the fact that we understand that quantum physics is the physical theory underlying the nuclear world. But quantum physics also, there is something more complex going on because there's the question that goes to the core of matter, and that is erased in pictures where there is a sense of clock time and the future of no future. And that is, what does quantum physics have to say about the nature of time? So this is the focus of the remainder of my talk. And as we'll see, according to quantum physics, there is no the future. The future is undone. So quantum physics not only deconstructs the determinism of Newtonian physics, where the future follows deterministically from the past, but it also blows away any progressive notion of time, as Benjamin calls it, the homogeneous and empty time, foiling first-world efforts to harness it as a totalizing system on behalf of universalism and imperialism. Quantum physics opens up radical spaces for exploring the possibilities for change inside hegemonic systems of domination. In important ways, its radical political imaginaries join forces with Afrofuturism and indigenous knowledges, rather than being a tool solely in the hands of the National Security Agency, although it is that too. But tools are never completely belong to the master. So, very quick presentation of some quantum physics. So, first of all, I want to focus your attention before we talk about time on the classic two-slit experiment, which tells us something about, in the Newtonian world, what is the nature of the ontology of the world. Okay? So according to Newtonian physics, there are only two kinds of entities. There are waves and there are particles. Particles take their place, one place at one moment of time, like everybody in a seat here. All right? Whereas waves, they aren't even entities. They're disturbances in fields or in media. And we know that waves can overlap with one another. There can be a wave that occupies multiple positions at the same time and multiple waves in the same place at the same time. And that gives this very different features. When you use a two-slit experiment, you get very different patterns, because for particles, in the bottom diagram there, you can see that if I have a barrier with two openings, most of the balls, the tennis balls in this case, are going to wind up on the wall directly across from the open doors. And that distribution of particles is shown in the graph all the way to the right. Whereas waves, they bulge firstly and bend around the barrier and push through the barrier, and they overlap on the other side of the barrier. And they give this very unique pattern, which is called a diffraction pattern, which has this alternating amplitude, okay? So very different characteristics. If you want to know if anything is a wave or a particle, then all you do is pass it through a two-slit apparatus. Now, in the 20th century, physicists realized that under certain kinds of experimental conditions, if you pass particles or ultimately anything else using the right conditions through a double-slit experiment, you can actually find it behaving like a wave. Now, this seems absolutely absurd on the face of it if we think about electrons as little particles, as we're inclined to do. Because I know that an electron, as a particle, would go through one slit or the other. But what I see here is that somehow the particle is going through both slits at once. Well, you might say there's a conspiracy of all the electrons that are being sprayed at the barrier at once, and somehow they organize themselves into alternating patterns, which seems like quite the conspiracy theory, but okay. We can get rid of that by shooting one electron through at a time. So I shoot one electron through, I watch where it hits on the screen, and I keep doing it thousands of times for different electrons, and I get a diffraction pattern. Now, Einstein suggested that this is a kind of something deep we don't understand here, because of course, if I were to have some kind of witch slit detector, I illuminate the slits with a flashlight or something else, that what I'm going to do is I'm going to catch it being a particle going through one slit or the other, so it wouldn't make any sense that, you know, I don't know how to reconcile or what I'm really doing, find a diffraction pattern. And Niels Bohr said, not so fast. Because if you insist on doing a witch slit experiment, you're not going to get a diffraction pattern. What you're going to see is a scatter pattern for particles. Now, this was just conjecture for a long time. but physicists took it very, very seriously. And you have to note that what's going on here is something quite extraordinary, because it's saying that depending upon how I measure it, I'm not just disturbing something and making it behave differently. What I'm actually doing is changing its ontology. That's quite extraordinary. So we're saying something like the nature of nature depends on how you measure it. Now, what Heisenberg proposed, and I've already set up poor Heisenberg, is that measurements disturb objects and they set a limit to what we can know. But as I just suggested to you by pointing out what's going on in terms of ontological difference, that seems unlikely. Bohr fought Heisenberg on this point very passionately. And Bohr said something that I think is one of the most unique things said in the history of physics, which is he said, if we want to understand this, we have to know what we mean by concepts. What are concepts? And he said something rather amazing, that concepts are specific material arrangements. Specific material arrangements. And he argued on the basis of this, and I don't have time to reproduce that here, that that will ultimately mean that there is no separability between the object and the apparatus. In the current lingua franca, we would say that they're entangled with one another, that there's an interaction of object and apparatus, which he called a phenomenon. And he said the world is made up of phenomena, not independently existing objects. Okay, so measurements, and in fact all other kinds of interactions, contribute to the ongoing materialization of the world. So this is quite the claim. And I want to just make one other point before I'm moving on rather too quickly in all of this, which is that what we're seeing now is there's something about the fact that there's an ontological indeterminacy, where it's not that we don't know which slit that the electron is going through according to Bohr, but rather it is ontologically indeterminate where the electron is. So there's an important sense in which it's going through both slits at once, one slit or the other, neither slit. All possibilities are happening. So this is saying, the physicists use the term superposition for this. It's a superposition of all possibilities, a sum of all possibilities. Now I want to talk to you about something that maybe you haven't seen before, which is instead of having slits distributed in space, what if we have them distributed in time? In other words, how about if I take a disk and carve some slits in the disk, and I have a laser beam that's running perpendicular to it. What you would expect, a priori, it seems, is that every time the laser beam is hitting the disk and a slit appears, it goes through, and otherwise it doesn't. It reflects back off, just like what we have with the slits distributed in space. And what you would probably expect is some electrons when it's open, no electrons, some electrons when it's open, no electrons, and that's not what you get at all. What you get when you look in time is a diffraction pattern. What does this mean? Now, you could do it both in space and time together. Okay? So what we're saying is there's some time indeterminacy principle, which in fact there is. Okay? And that in fact there's a superposition of times. That it's not that the particle goes through only one slit, so only one time, but at a given, it's even hard to say this because our imaginations are so constrained when it comes to talking about time. But at a given time, as it were, or at a given place, there's multiple times that it's going through the slits at the same time, something like that. An entanglement of times, all right? And what this brings to the fore then is the fact that there isn't just space and time as givens. Space and time are not given, but space and time are iteratively, interactively produced, depending upon our interactions. Space-time mattering are produced. And the best visual representation I found is this film that Camille Utterbach did called Liquid Time, where you interact with it and you get different time slices happening simultaneously, as it were, or something like that. The next thing that I want to introduce you to with regard to thinking time differently and what quantum physics has to say about time takes us back to the two-slit experiment in space that I was talking about shortly ago. And as I mentioned to you, this had been a thought experiment that Einstein and Bohr argued passionately about in the 1920s and 1930s. But the experiment was actually not done until the 1990s. And then physicists actually designed a phenomenal experiment. It's really an amazing, gorgeous, ingenious experiment that challenges the distinction, in fact, between physics and metaphysics. Because between Bohr and Heisenberg, there's a sense in which there's a metaphysical distinction. Because Heisenberg says there's something there that we disturb, and Bohr's saying there isn't a there before there's a measurement. And so how can I make a measurement to decide the difference between them when the difference between them is what happens before a measurement? But actually, there's a gorgeous way to do this. What physicists did was they designed a witch slit detector, right? That's what you want. But instead of a flashlight here, it's something a bit more complicated that I can't go into right now, but just it's like a flashlight, okay? And it's detecting which slit, in this case, atoms, rubidium atoms, are being used. And it's detecting which slit the rubidium atom is actually going through. So just to make things simple without going into details, they've designed this witch slit detector in just such a way that there is no disturbance of the forward momentum of the rubidium atom. So Heisenberg is hardwired out of this experiment. If this experiment works, it's not because of a disturbance, because that's how it's designed. So we do this experiment, and the first thing is we don't have a witch slit detector, and lo and behold, we get a diffraction pattern of the atoms on the screen. That's what we expected. That's what we've seen lots of times. Now we put in the witch slit detector. What do we see? Is Einstein right or Bohr? Well, we don't get a diffraction pattern anymore when we do the witch slit detection experiment, and that vindicates Bohr. But then, that would be enough. That would have been enough of a contribution. But then the scientists, the physicists said, wow, if there's no disturbance here, then I can take away, after the fact, I can erase the information of which slit it had gone through. Can I get the diffraction pattern back? Right? And so that's what they tried. That's called the quantum eraser experiment. And they went ahead and did this. They erased so in other words, the atom's on its way through. It goes through which slit detector. It makes a mark about which slit it goes through. It goes on and hits the screen. Boom, it's on the screen. Now you decide afterwards whether to erase the information about which slit it has gone through. Okay? And when you do that, you get a diffraction pattern. Now let's pay attention to that. Because what I'm saying here is after the atom has already gone through the double slits and the witch slit detector and left a mark about which slit it's gone through. It's definitely gone through one slit or the other. It hits the screen, and now I erase the information about which slit it's gone through, which means after it's already hit the screen and gone through the slits, I can decide whether or not it will have gone through one slit or the other as a good particle does, or through both slits at once as a good wave does. After the fact, I will have decided. Okay? So there's something very strange going on here with temporality. Have physicists figured out how to change the past? And that's in fact what was suggested in the paper. And I've argued that a better way to understand it is not so much that they change a past that always already exists, like in Back to the Future, you just go back to the past that's there, okay? But there's an important sense in which what the experiment is telling us is the past is always open. In fact, the past is yet to come. It's not left behind. And that's not merely subjectively, but ontologically, okay? But what's really important in this is that what the physicists had talked about is the fact that a diffraction pattern would be recovered, and it's not recovered. It's a new diffraction pattern. And so what's so important about this is it turns out that when you make erasures, you leave traces in the world. Okay? And so I have claimed very much both tongue-in-cheek and meaning it at the same time, because that would only be appropriate, to annoy my fellow Derridians, that this is empirical evidence for a Derridian ontology. All right. There's amazing things to go through in terms of quantum field theory, but I don't have very much time here, so I'm just going to take you through a few points about this. First of all, suppose I take a diffraction grating now, and I have, instead of 2 slits, I make 3 slits, or I make 4 slits, or 10, or 1,000, or 1,000,000, or something. And then I have multiple diffraction gratings. You can see that this is multiplying and the superposition until it gets to the point that if I'm trying to get from point A to point B, what I have to do is take the sum over all possible paths between point A and point B. It's not that one path is being picked out over all others, all right? But it's actually that there's a sum over all possible histories here that makes up the diffraction pattern. Furthermore, now this is something I really don't have time to get into, but there are important ways in which particles actually interact with all other particles in terms of being themselves. They're only themselves through all others. So particles have to interact through all others in order to be what they are, meaning that, and these particles are virtual particles of the vacuum, and the vacuum is not separable from what matter is, okay? So what we have to do is sum over all possible interactions of matter or time beings or matterings, however we want to call this. And what you wind up understanding then through some very complicated mathematics is that even a point, like a point particle, like an electron, is just a point. It has no interior. It has nothing going on inside of it, supposedly, except actually everything is going on inside of it. There's everything. There's the entire world in a very specific configuration. That's not the same as a proton. Having the whole world inside of it. So there's a sense in which time and being have this thickness to it. The thick now, this particular moment now, has all times in it. So I'm about to conclude. In her book, Afrofuturism, Ytasha Womack writes, "Whether the future is now or the past is the future really depends on the actions taken today." By way of gesturing towards some of the ways quantum physics thinks temporality anew, an undoing of the presumption of a singular future built on singular moments, empty moments devoid of the past, I want to conclude by bringing to the fore some of the temporal entanglements that are contained in the time being of an atom. Every tiny bit of matter, every moment of time. In her amazing novella, From Trinity to Trinity, Kyoko Hayashi provides us with a time-hopping tale of bodily tracing the entanglements of the bombing of Nagasaki on August 9th, 1945, back to Trinity Site and the bombing of indigenous lands. Tracy Voiles, in her book Wastelanding, attends to the entanglements between uranium mining on Navajo lands in the U.S. Southwest and the ongoingness of U.S. settler colonialism of native lands. The fact that U.S. settler colonialism is not a thing of the past, but alive in the thick now of the present, is on our news feeds every day now in light of the history-making protests at Standing Rock, which are about future-making through taking account of the injustices of the past that live in the present. The material entanglements of the bombs dropped on Japan reached to the continent of Africa and what has become the global uranium trade. Gabriel Hecht traces these material entanglements. The uranium for the Hiroshima bomb came from the Belgian Congo. In any given year of the Cold War, between a fifth and a half of the world's uranium came from Africa. Quantum physics champions the undoing of homogeneous empty time in multiple ways. This is one of its deconstructive seeds that undoes the alleged totality of globalism. Quantum physics blasts open the continuum of history, as Benjamin would put it. It opens up radical political possibilities and enlarges the space of agency, including understanding this moment here now to be a dense seed filled with other times and spaces. The past is alive in the thick now of the present, not merely as subjective personal experience or even only as social reality, but ontologically and materially. These are openings that might align with and serve a decolonial politics. Why might this be? Why might this work? The point is not one of making analogies between the social world and the world of the atom. The point is what quantum physics tells us about what a point is. In this relational ontology, there is a strange topology, a world inside each point, each tiny bit, each moment. Quantum physics and indigenous ontoepistemologies are not parallel stories. They are materially entangled, shot through with one another in the specific space-time matterings that constitute worlds. Not only is the bomb inside the atom, but so too is the land of Turtle Island people and other lands, and so too are the space-time story theory doings of indigenous peoples. Thank you for your time.